So I want to talk a little bit about proportions. That's our next topic here. Topic number 6 for this series for chapter 1. Theoretically, proportions are covered in math classes. I've seen it come up in textbooks, either in like elementary or intermediate algebra, or possibly for high school, like algebra 1 or algebra 2. Sometimes a little bit in one class, a little in the other class, or sometimes it's lumped into one, depending on what curriculum is being followed. But I cover it here because my experience has been is that a lot of times people will come into a physics class and we start saying stuff like, oh, well, this is proportional to that. And then we start writing something and everybody gets lost. So I want to kind of review these methods. If you don't get them all today, that's understandable. What I've written here on the key concepts page could have easily been maybe straight copied out of a very mathematical math book. I don't even know what that means, but maybe you know what I mean by that. So it can be a little bit daunting to look at this, but when we look at the examples, I think you'll see that the methods are reasonably straightforward, and I'm going to kind of ask people to try to practice these as the semester progresses. They tend to come up in homework problems. They come up a lot in physics in general because one could argue that physics is all about proportions, and proportions are all about how quantities relate to each other, and that's really physics looks at nature and looks at how they relate in a very simple way and often mathematical way. So the first statement there says what it means for a variable a is proportional to a variable b. That means that there exists some k, which is really, we're going to call that the proportionality constant, such that a would be equal to whatever that k is times b always. And then in the next line here on the key concepts, it says if a is proportional to b, this, so we're going to get used to this language here. In other words, this, when I write something like this, a is proportional to b, that symbol for is proportional to looks a lot like the Greek letter alpha, and when I write it, they're pretty much indistinguishable. In the program I used to write this here, though, this is an actual special symbol for proportional to that does actually look different than the alpha in that program, but nevertheless, they are very similar looking. But this, again, that's what that means. Just a is proportional to b. And in that sense, I could say mathematically, I could restate this first statement as to simply be saying that means there's an a is equal to a k times b for some k that exists, that maybe I know it, maybe I don't know what it is. But this second statement is saying something different, because if this is true for all possible paired values, because the way we think about a and b are variables, but if you give me a value for b, this equation should tell you what the value for a is. And in turn, if you gave me a value for a, I could find what the value for b is by this equation. So if I had a pair of such values, if I had like an a1 as 2 paired and a b1, and then maybe I also had a second pair of values for the same variables represented by a2 and b2. It's kind of like ordered pairs of x and y's maybe, but we're not going to graph it here. The claim is that this relationship here, the ratio between the a2 and a1 should be equal to b2 and b1 if a is proportional to b. In fact, you can actually look up, I remember looking up on the internet at one point a definition of proportions, and it actually stated something very similar to this. It just had, I think it used different notation. It wasn't as clear about how things were paired. It was just like, hey, an a over a b is equal to c over d or something like that. So again, the pairing there was not very clear, but it basically said anytime you have this kind of relationship, that means there's a proportion. So that's another definition I've seen out there online. It's not quite the starting definition. I'm looking at it more from the perspective of like, hey, this defines a proportion, but this is also a true statement. And how do we know that? Well, if this is true, then a1 is equal to k, b1 is going to also be true. A2, the other pair, would have to identify following the same equation. So a2 would equal to k, b2. And now if I said, let's take this second equation and divide it by the first. So that would be like take left side, divide by left side. So that would mean a2 over a1 for that. And on the right side, I would get k b2 over k b1. And the nifty thing that happens is those k's cancel out, and that's where I get that result. Oops, b2 over b1 that I've stated right here. Now, maybe before I move on, I've taught this class for a number of years, and it's usually when I get to this topic that at least a few people start running for the door screaming or something like that. So If you're watching this video online, don't go running and screaming for the room, or don't hit close and leave this class. I presented this very mathematically. In the examples, I'm going to try to show this a lot more like common sense level, I guess you could say. So don't be too scared. But again, I'm just kind of getting us warmed up with some definitions here. It gets a little more hairy in these next two right here. A is proportional to b to the r. This opens up the possibility of exponents. In other words, r represents just some exponent. It could be squared, could be cubed, could even be equal to 1/2, which will represent a square root. So we can do this with square roots as well. But if you have an exponent like that, saying that a is proportional to b raised to some power means there exists a proportionality constant so that a is equal to that constant times b raised to that power. And it turns out if you followed similar kinds of steps as I did right here, you'd get a similar result for the proportions relationship. If you take the ratio of the a's for two sets of paired values, it would be equal to the ratio of the b's, but in this case, raised to that same power that I was given. So that's also a result that we're going to want to be able to use in some instances.